follow with the presentation. Let me know if I move away from the camera, since I can't see myself right now. As said, I am Lamine Diallo. The objectives today, we will talk about filterability, the tips and tricks that you can do to help you during membrane filtration. We will talk about microbial recovery, which is the end goal, obviously, after filtration. And I will also discuss some of the success examples that we did have here in the lab. Can you hear me?
Yes.
Yes, we can. Now we can.
Somebody muted me by accident or so. Okay. I'm not sure how much you heard, but I will start again. We will be talking about filterability. As it is, filtration is the recommended method, if possible, by the USP in the industry. We all know that's easier said than done. It can be challenging. It does have its advantages, though, when it's possible. One of the advantages is, you can filter as much as possible. Compared to direct inoculation, which you can only inoculate so much of the product. Why is that? Because you only have a certain amount of media that you need to inoculate your product in. If you put too much product, it becomes so cloudy you wouldn't be able to read it. From my experience, I know even for a 1 liter media TSB media bottle, if you inoculate even 20 mils, it gets so cloudy that after the 14 days incubation, sometimes you will have to take a sample of that and inoculate a fresh bottle of 1 liter media and incubate for an extra 4 days, 18 days, which is a lot in the industry for incubation. Okay, so another advantage it has is it does help you remove inhibitions on your product, because when you filter, you will also have a chance to rinse it. Rinsing helps you to neutralize any inhibitory properties that are in your product. That is another advantage. You can filter as much as possible. As much as the filter can take, which is a lot. And you also have this advantage of rinsing, which also helps remove the inhibitory properties, which will help you in your recovery. So we'll talk about the tips, we'll talk about microbial recovery, we'll talk about success examples. So okay. Next would be the product types. When you talk about filtration, obviously different products will give you different challenges. We have group products into 4 different groups. Some people use only 3 groups. Easy, which is mostly your aqueous, liquid, easy pharmaceutical products, buffers that you can easily just filter straight and it goes through, no issues. Group B would be the ones that require method development. This method development could be as easy as just diluting. These could be lyo products that are easy to filter. It could be products that would need some kind of tweaking. You may dilute and it may not filter right away. It could need a little tweaking based on what type of liquid you would use. You may warm your product, your diluent a little bit to help you. Then we have the complex products, the complex method development products. These are products that easy dilutions don't help you. Just reconstitution may not help you. These are products that may need warming may not be enough. You may have to use IPM or like enzymes. You could use enzymes. Enzymes are possible. IPM, isopropyl, myristate, and some other stuff that would help you either digest or dilute the product to be filtered. And there are other products that no matter what you do, some suspensions especially, you may not be able to filter them. And these ones, you may not be left with any choice but direct inoculation. Any questions so far?
Everything's open.
All right. So with the different types of products, you also have different membranes. Easy to filter products. You can easily use the MCE or mixed cellulose ester membranes, which I have here. If you can see, those are the graded ones. They have the grades. They are the most basic that we use. Or the ones with the PVDF. These are colored pink because we use it for our rapid system. We do have the same as these, but the colored one we use for the rapid system. And you can see these are PVDF, and they are not graded. The advantages, obviously, of the PVDF is their ability to allow you to filter, and they are low binding, so it makes it difficult for proteins to bind, which makes it easier for you during rinsing to remove all the inhibition. They can also be categorized with pore size. I mean, the most common I see is 0.22 and the 0.45. The most common I use, mostly in the industry that I see, is the 0.45 micron. The reason being, they have been stated to be the best in recovery. 0.22 are best in retaining microorganisms, but for the microorganisms of interest in the industry, the 0.45 are better in the recovery, because you want to retain them during filtration, but you also want to make sure they grow. So you can recover them to determine your recovery percentage. So during method development, you have different various steps. Obviously, you have to choose the right membrane. When you have simple buffers, obviously you just jump on, straight away that you would try the MCE membranes. Most likely those are the ones you would need. If you have antibiotics, definitely you would need to use the PVDF. If this is sterility, again, this filtration is applicable for both sterility testing and membrane filter and bioburden testing. For instance, for sterility testing, we have the blue canisters here. These ones I showed you, where rapid. We use the Milliflex for the rapid sterility testing. But if you're talking about sterility testing using the Symbio pump, which is behind me here, you would have to use the canisters. And these canisters have the different membranes we already talked about. These blue come with the MCE membrane. So all these regular product buffers and stuff, you would need the blue canister. You would straight away go to these because you will know that they would filter. And again, it's not just about filtration. It's about filtration and also recovery, which is the end goal. So, but if you have antibiotics, you would need this, which have the PVDF, our red-based canisters, which comes with the PVDF membrane. This makes it pretty easy to filter, and also makes it easier to remove the inhibitory properties. It helps for microbial recovery, because we all know antibiotics, very challenging to recover microorganisms from that. Sometimes even the canister, just the canister alone may not be enough. This is where you would have to choose wisely what diluent you would use with your product. If it is oily, greasy, we have the green base, which helps us, filter, well, also helps you during recovery. It allows you to use all the fluids, even up fluid K, up to IPM. I will talk about the fluids pretty next. So we also have this. I don't have the Oasis pump, but we do have MCE membranes, all the different types of membranes that come with the consumables for the Oasis as well. So now we've talked about these three SteriTest Neo, blue, red, and green canisters. Once you choose either canisters or funnels that you would use for your product, you would now, it's time to decide what type of fluid. We have a fluid A. I don't know if you can see. We have the fluid A, which is the most basic. We just uses 1 ml of the peptic digest. We have fluid D. We have the fluid D, which is a step above. It's just a higher concentration of the peptic digest. From the fluid A, you just add a little more. Then we have fluid K, which also has the beef extract and also polysorbate 80 added to it, which usually for oily products, greasy products, this is the recommended fluid to use. You can use this by themselves. You can use them in combination as well. We always recommend, if you use fluid K especially, to have your last rinse, fluid A as your last rinse, because as good as it is in removing inhibitory properties, it can also hinder the growth of microorganisms. So you want to rinse it at the end. So your last rinse that you usually add your microorganism, we always recommend to make sure it's fluid A instead of fluid K. If fluid K doesn't work, one of the issues we have, IPM. There's the magic solution for most of the greasy stuff that people have challenges in. My experience, it's always been an issue. And even when you get it, the other challenge mostly is, can you have a steroid? Because as we all know, in sterility testing, the less intrusion for your product, the better for you. People freak out even when you tell them to add. The more you add, the more manipulation you add, the higher the risk is. So imagine having to use IPM. That's not steroid. You have to sterilize it yourself, then use it. This is an added risk in the industry. It's a nervous part of testing that most people would worry, because you don't want to add anything to your product, because then not only you have to determine what's the cost in case of growth, you don't want, now you have to decide, you have to determine whether it was the IPM you sterilized, whether it was enough. And if it doesn't work at room temperature, it's always recommended to warm it up to 40, sometimes 44, but not too high, because it can also kill microorganisms. Another challenge arises from that. If you have to use an isolator, one of the challenges they have is, how do we warm it? Because you're going to have to run sterilization cycle in the isolator. And some of the challenges people have is, how do we warm this? So if you're going to be testing in an isolator, from the get-go, can make arrangements to have something in there that will help you, a warm plate or something hot plate that will help you warm, if possible. Validated with it, warm your IPMs. Okay. There are differences between, obviously, in concentration. If you have a direct buffer, easy to filter, most of the time fluid A 3 times 100 rinse would help. Sometimes if that doesn't help, you'll go to the next one, which is fluid D. But if you have an antibiotic, it will be useless to start with fluid A. You will go straight to your fluid D to start, if that would work. Do a mix. Another thing that helps you during filtration especially, it's to pre-wet your filter. When you pre-wet, these filters have, they have membranes. They have pores in their membranes. What we always want is, the less you have the product bind to those membranes, the better for you during neutralization, especially during rinsing. The more they bind, the harder it is during rinsing to remove. So what do? You pre-wet your filter. I always recommend 50 mils. Some people do less. You add 50 mils of your diluent. Fluid K helps a lot if that's what you're going to use. Then you filter it slowly, speed of 40 mostly, because why slowly? Because you want to delay to give it enough time to engage your membrane. So then after that, my experience, you can go straight to your product. But I like to put another 50 mils of the diluent. That way when I start filtering the product, it's not directly on the filter. The product comes in a little diluted. The first part of the product that gets in contact with the membrane, it's a little diluted. It's not as strong when it gets in contact. So if there is any more space for it to bind, it is the weaker version of the product that binds. That way, the stronger version of the product, the stronger concentration of the product will pass through. So you want to choose the right. You may not see the difference in the filtration in terms of the diluent, except obviously if you need IPM. But it's going to come in handy during recovery, because if you use the right diluent, you will see that your recovery will be better, which is why it's challenging. Do you just use fluid A or fluid D, then wait 4 to 5 days to see if you use another one? I always advise use different combinations, different rinsing schemes, okay? I always say use different rinsing schemes, because when you use fluid A, then you use fluid D, or you mix it up, from the get-go, whichever gives you the best recovery, you will go with that. It saves you a lot of time. I know it's easier said than done because you don't want to use too much resources, which is why some people outsource method development part of these microbiology, of these tests. It could be time consuming. It could be very tedious. So sometimes you want to let, your employees, obviously your staff work, especially if you have running, you're doing release testing, having to spend this much time on method development can be challenging. Resources can be challenging. Okay, we talked about speed already. This is what I recommend. This is what is recommended. The speed, slow for pre-wetting. We want a high speed for your product because we want to give it less time to bind with your membrane. We want to give it less time. But we also know that for sterility testing in the canisters, the higher the speed, it could generate some pressure in there. This is where you can try to tilt your canister sometimes to help release the pressure, in the canister. It also helps a little bit. So I just talked about the rinsing scheme. Different rinsing schemes, different combinations. If you can afford it, it saves you time. That way, after 4 to 5 days, you can decide whatever is best to use. And for filtration also, that just may not be enough. You may have to use, if you have cell-based products, you may have to use, if you have cell-based product, you may have to use cell lysis. One common one that we have here that we use, the mammalian cell lysis solution, MCLS in short, which also helps. You will see that if you can't filter cells, you will be able to filter them with this help and apiarase enzymes that help it. Enzymes are also there for the pharmaceutical products. For instance, cellulose-based, you may use cellulases that helps you filter the product. If I'm going too fast, please let me know. So in recovery, what are we trying to do when we filter? We're trying to remove the inhibitory properties. We're trying to neutralize them. We're trying to remove them. Dilutions help. When you dilute the product, obviously, make it weaker. When it's weaker, it's easier to, then the weaker version of it combines, and it's also easy to remove during rinsing. We talked about the different rinse fluids. I just mentioned enzymes. And sometimes there are media additives that you can use, because you'll see that whatever helps you in filtration doesn't necessarily help you during recovery, because you may be able to filter with the help of enzymes, rinse fluids. Then at the end of the 5 days, you say, oops, it still doesn't grow. You may need media additives. There are things that you add, like magnesium. When you add it in your media, it helps you. It helps recover. It helps you in recovery of organisms, especially if you have antibiotics. It helps you neutralize them. Okay? So any questions so far? Because I may have to. Yeah? Okay. So I have some special cases that I wanted to talk to you guys about. Um, there was a case that we have stem cells, and we try to filter it. The density of 10 to the 5 filtered pretty easy, no help. We didn't even need to lyse it. We didn't even need to lyse it. But then we moved it up to 10 to the 6. We could not even filter it. We then had to use the mammalian cell lysis solution to filter it. It helped a little bit, but it wasn't enough. We had to add the apiarase enzymes. And for 10 to the 6, we had to use 4 mils per every mil and 5 units of apiarase enzymes. That was what helped us to be able to filter this product. As it goes higher, the density goes higher, it becomes more difficult. You will see that the higher it goes to a certain point, even the mammalian cell lysis solution with apiarase may not be able to help, depending on how much volume you're trying to filter. We have this other case, a cellulose-based product, where we could not filter it. We had to use cellulase, mix it with cellulase, and let it stand at room temperature for 30 minutes to let it filter. This allowed us to filter it, but at the end, it still had some active ingredients that didn't give us a good recovery. What did we do? We added the inactivator broth, deactivator broth, and let it sit for 10 minutes after the cellulase. That was how we were able to get a good recovery, passing recovery from it. There was a different situation where we had an antibiotic from the group fluoroquinolone. We did everything. We pulled it down to 1 mil. Still, imagine 1 mil with 5 times 100 mils of fluid D, it still would not give us a good recovery. It filtered fine, but we didn't have a good recovery. We did some research. We found out that magnesium sulfate can help us deactivate the antibiotic. So what we ended up doing is, at the end of the filtration, when we spiked with the last rinse, we also filtered the filter with 10 mils of magnesium sulfate, and this was homemade. We added magnesium sulfate, we diluted it in the lab, then we used our 0.22 filters to sterilize it, and we used 10 ml, filtered it, boom, we got a good recovery. And the customer was really happy with that, and that's the method they're using in the lab currently. There was another situation where it was antibiotic from the beta-lactam group. What worked, after trying several different rinsing schemes, we had to spike the media with 1 ml of beta-lactamase enzyme. We spike it with that, and that's how we were able to activate it and get a good recovery. For an oily product, we tried room temperature, the IPM I was talking about. At the time, we didn't have that. I've been with Millipore for close to 5 years, and one of the things my colleagues and I always talked about, oh, how great would it be if we have the ready-to-use IPM? How great would it be if we have the ready-to-use IPM? Because you're always nervous when you have to sterilize it yourself through filtration in the lab and add it to your product, because you want to make sure you're not adding anything to it. And at this time, I mean, it worked for us. Room temperature didn't work, but we had to use it. We had to warm it to 40 degrees for it to work. And we used it in combination with fluid K, and the last rinse was fluid A. There were certain situations where we had to use 2 times 100 fluid A. We'll use 3 times 100 fluid K and 2 times 100 fluid A to get it to work. And last but not the least of our examples, we had a time where we used shampoo. We didn't have saline in my list, but obviously PBS, saline, any sterile diluent, there's a lot. Even sterile WFI is available to use as a diluent. In this case, it was a shampoo. It was a citrus-based shampoo, actually. We tried. We ended up having to do several dilutions. 1 to 50 didn't work. 1 to 10 didn't work. We did a 1 to 100 dilution in saline with 0.5% polysorbate 80. The dilution helped us with filtration, but to get a good recovery, we had to add the 0.5% polysorbate 80, which is what helped us deactivate it to get a good passing result for the customer, and they were happy with it. These are the examples I have. I will welcome any questions if you have any questions or any comments.
There's nothing so far.
Hello?
Yep.
Can you hear me?
Yes.
Yes. Oh, okay. Do we have any questions? Or?
At this time, we don't.
Okay.
We have a question. Any work with microspheres?
No, I have not. Oh, let me see. Okay.
What type of membrane does the green canister have? That's the question.
PVDF.
How does it differ from the red canister?
The red canister, they both use PVDF, but the difference with the red canister is it's for antibiotics. It's in the low. They both have some low binding, but the red canister is specific for antibiotics. Some of my colleagues here may be able to add more on that, but that's the difference. One of them, and it's made specifically for oily. The other one is made specifically for antibiotics, but they are both PVDF.
Yeah. Hey, Lamine, it's Tim. The green canister, the material of the green canister is nylon or Grilamid, so it can withstand solvents. That's the main difference. It also has a base that's different. The base is basically built to withstand more pressure because the solvent is going to be thicker and you're going to need more pressure to drive that solvent through the filter. So the materials are different. The filters are the same, but the materials for both for the actual canister itself is different.
Thank you, Tim.
Lamine, a common question is, why a maximum of 5 rinses?
That's a recommendation in the industry by USP, but it's not. It's not. If you can justify going beyond, you can. As a matter of fact, my past experience, we do have a product that we were using up to 10 times 100 rinse. We had to justify it because it was the only available option for us. We couldn't. 5 couldn't do it.
Yeah, and I looked this up with I looked up articles and I asked USP, and the number actually doesn't exist for any specific scientific reason, other than they figured if you couldn't do it after 5, it wasn't going to be able to be done.
Right.
And so there's really no scientific reason other than maybe some peptone buildup on the membrane that you might end up if you're using, a lot of fluid D or something like that. Certainly not fluid K, but there wasn't. So people have asked me that, and I say, there's no scientific reason at all. It just exists.
Okay. There's another question from, is it
Blanca? Yeah, she's
Blanca?
asking. Yeah, she's asking about the filtration for the pumps, and basically about the pre-wetting of the membrane for the filtration. So I guess she's asking, is there a better filtration rate than another, and what's too fast, what's too slow, etc.?
Yes, I always recommend you can change it. There's a knob that helps you change. Pre-wetting, I always recommend slow, about 40 max. When you do your product, you can go 60. I go 60, 65. If you're going to do 70, I don't want you to do storage. I'd never recommend going 70 for a long period of time. If you're going to do 70, But if you're gonna be using it for like 4 hours, going 70 may not be advisable, because it it may not be sustainable. But yes, you go low for pre-wetting, high for the product, then you slow down also for your media, especially for your FTM, because the higher the speed for FTM generates more oxygenation, and you don't want that. For FTM, I always recommend 35 speed. With TSB, you can go a little higher, even 40, 45. Yes, with the splicing, which is why I always, which it's always good when you have a liquid inside your canisters. When it's there, then you start filtering your product. That's where you start. And don't wait until everything is empty in your canister, because then that's where you create splicing. What I always do is you will filter before, and make sure that the filter is all engaged the entire time, because if the filter is not engaged with the liquid, it does get dry, and when it gets dry, it actually gets more difficult. It's difficult. It's more difficult to remove the inhibitory properties. I would always have liquid covered. I would have the filter covered with liquid at all times if you have liquid going on. That helps you avoid splashing as well. And if there's nothing in there, you can always start with low speed and increase to higher speed to just avoid that. Once you have enough liquid inside your canister, then you can increase the speed of filtration as well.
Hey, Lamine, how often do you find people are not pre-wetting their membranes?
A lot, actually. I have, to be honest, I have seen it. I mean, it's pretty common. I talk about it. Some people get surprised and say, "Oh, really?" To be honest, even myself, before I actually joined Millipore, I had never done pre-wetting before. I had never done. It is when I joined Millipore I learned about the pre-wetting, but before we never, I had never practiced it. But it does really make a difference. It does really help, especially
I think
with
it's the first. It's the
Yeah.
first thing
Yeah.
I think we talk to people about. If they're having problems, it's the first thing is, are you pre-wetting?
Yes.
And I'd say most who are having problems,
Yeah.
most are not pre-wetting.
Yes. Yes. A lot of them, and it has helped a lot. People have called, will recommend it, and they will try it, and they will say it did really improve their recovery. Not allowing to let your filter dry up helps a lot. Keep it moist.
Yeah.
I always recommend leaving a layer of about 10 mils in there, not emptying the whole liquid. If it does, let it stay wet. It's always better to leave a layer of diluent on your filter before, unless it's time to add the media. Don't let it dry out, but you can let the whole diluent filter through while it's still wet, then add your.
It's a funny thing how people think they need to separate those, huh?
Yes.
Because they're thinking, okay, I have this and I have this product, and they have to stay separate because I want to. You're so used to that thinking of purity and sterility and aseptic technique, but when sterility testing, it's all going through the filter.
Yes. Yes.
Lamine, we have another question. How do you recommend accessing the media in the closed membrane canister for an investigation purpose after a sterility test?
Syringe needle. Syringe and needle is what I do. You go from the top, go straight through the tubing, and access the media. Normally, once you do that, you are done incubation, so you can access it if you need to plate it through the top. That's what I've seen, and that's what I've been doing myself for verification.
Hey, Lamine, how often do you see people using the wrong canister?
It has not as, yeah, go ahead.
No,
Okay. I wouldn't say wrong, but there are situations where you're using a canister and it's working out, but there's a better one to use, better option to use instead. I have seen that. I have seen that where instead of using, for instance, especially with the blue canisters, you know the membranes are, it's the same membrane. I mean, there's a situation where somebody would use one for small vials instead of large vials, or one for plastic. It's pretty common. And sometimes you will see that you may have a product with an active ingredient and you're using, sometimes you can get away with blue. But there's a lot of times where if you had moved to the red canister, you would have been much better. You'll have a better recovery than. Why is this important? You may think this would help you with false negatives, because you could be using a canister, you're thinking this is giving you the best recovery or it's getting later along, not knowing that another canister would have been able to catch stuff that this one would not be. So it's always good to, do your comparisons. If there's an active ingredient, recovery is pretty low. And this brings me here. We have this practice here at Millipore where even for theory tests, before we go to the canisters, we'll try to do a quantitative recovery for us. Some people say it's not necessary, it's not a requirement. Yes, it's not a requirement, but if you have a method that's going to give you, let's say, 90% recovery, it's better than a method that's going to give you 55% recovery. It's more robust. So we do that and compare the one with the best recovery, and then we will move to the steady test canisters. And how do we this comparison actually does help, because if you go straight to steady test, it's qualitative. You look at the cloudiness, you wouldn't be able to determine sometimes which one is more robust based on the cloudiness. But if you do a quantitative one using the funnels, that would give you a clear indication of which method is more robust before you move to steady test.
That's a good point, to do a quantification inhibition study in the lab to determine if the method of the actual sterility test is, which one is least inhibitory. Yeah, that's a good point.
Yes, yes, yeah, yes.
And did you talk, sorry, I missed the beginning. Did you talk about the difference in filtration rates between the blue and the red and the green, as far as which ones filter faster?
No, I did not. I did not.
Yeah, we recommend the blue. And blue has the most options from the canister sets, and the blue will filter faster because the MCE membrane is what we would call, I guess, the porosity is looser compared to the porosity of the PVDF. So I guess when we're talking here about membrane, method development and method optimization, if we can choose the blue MCE, you should choose the blue MCE. That's going to be your fast filtration, most needle configurations. And the red is reserved for, like Lamine said, the antibiotics and other products that might not be compatible with MCE.
Any more questions, comments?
Doesn't appear to be at this time. Here we have another one. Do pressure variations from the Symbio pump impact organism recovery?
Not from my experience, because not from my experience. But there's one thing you don't want to do, because you don't want to slam. That's one thing, a favorite statement that they will use, that you just don't want to dive into a swimming pool without water. So we always say that once you're doing your organisms also, you don't want to splash them like that, because you also want to protect them. But apart from that, you should be okay. If the pressure is bad, the pump will tell you, we have a pressure regulation. pressure regulator there that would shut down the pump and warn you before all that. Once the pressure gets too high for your method development, the pump will tell you it. But I wouldn't do anything more than 50 during rinsing, especially with your organisms. Your last, I wouldn't do more than that during rinsing, because when you rinse, you don't want to rinse at 60 or 70. I do understand, especially with certain medical devices, sometimes you have a lot of stuff to filter. With the product, you can go high, but with rinsing, you want it moderate. You don't want it too high, because you want to allow the diluent to give you maximum contact as much as possible with the filter, with the membrane, to remove all the inhibitory properties.
Over time, we've seen people where a method where their method would say rinse the canister with fluid A, use 100 mils to rinse the filter, excuse me. Yeah. And what they wouldn't have put in there necessarily is the speed. And so we have found where people have cranked up their pumps to 150, and they are rinsing as fast as the pump will go because of speed, because they want to get out of that isolator as fast as they can. And that is not the way to go. We have seen where those methods have kind of been a little loose. You want to definitely designate the speed so that you don't have a user who says, hey, I can go faster. Why not? I can get out of here faster. That's definitely not optimal.
And guys, this is Juliana. Another thing I wanted to point out here in regards to the speed is the needle. Depending on the needle configuration that you have, it does make a difference on the splitting. You want to make sure that the liquid is being equally splitting between the two canisters. And if you're going too fast, you might not get the equal splitting or very close splitting between the two. So this is one of the biggest concerns with going too fast. And this is something we do during the IQOQ of the pump on the validation protocol. It does state the catalog number of that particular canister that you're using based on the needle configuration, and there's the highest speed for that particular type. There is a full table on the validation protocol that gives you that ratio of what is recommended, the maximum that is recommended. Some of them, yeah, you can go up to 150, like the big needles for the large volumes, but there are some that don't recommend you to go above 40. So this is something that you definitely want to pay attention to. And you can also address this during method development, that you can check the speeds just based on the equality of how equally you are seeing them go up on the canister. Or you can also weight the liquid that you get after. So let's say you have 100 ml sample or 100 ml of liquid, and you do a speed of 40. Then you collect that liquid and you weigh it, and you see, and it should be within 10% of each other, and you see what the difference is. If the difference is too much, then you might want, okay, if I go a little bit slower, maybe it will help on that splitting a little bit, and you can improve it that way as well. But this is very important, especially when you're talking about the sample.
Thank you, Juliana. Good point. There's another question from Blanca. Is IPM? Go ahead.
Is IPM recommended to be used as a rinse after filtering the product or a diluent?
No. Whenever you use IPM, we recommend using fluid K. You can warm the fluid K as well. You use fluid K and fluid A. Because you want to remove that IPM from the product.
Yeah, IPM is just a solvent that's designed to allow a non-filterable product to become filterable. And it's technically doesn't have antimicrobial properties, but some people have found that it does inhibit in their product for whatever reason. Not that it doesn't, but it's written into USB 71. Yeah. So it's really just a solvent meant to dissolve your product. At that point, like Lamine just said, all the rinse fluids should be used after that.
Any other questions, comments? If there is no more, and again, I thank you so much on behalf of the team. Thank you so much for joining this session. One more question.
IPT testing.
It says for IPT testing?
Yeah.
In process?
Some
Test?
people. So, yeah.
Pre-wet for water.
Water testing. Actually,
Yeah.
my experience with water is direct. No pre-wetting, not even a rinse. You just test the water straight. Unless if it is industrial. There are some that industrial, for instance, if you're testing anything less than, if it is 10 mils, you may need to do that just so that you have enough to occupy the whole filter. Because the reason they only do a small portion is because of the count in process testing. Because if you do 100 mils, 200 sometimes is just too numerous to count. So you may do a little bit. In that case, you may need to pre-wet, just something to engage the filter to spread it wide. But apart from that, if it is just regular WFI, no need to, definitely no need to pre-wet. Just test, and there's no rinse. Yes. Correct. Yeah. It helps you spread the water.
Your sample.
If there's no more, I guess